All right, so today we're going to plow forward with our continuing series of programming basics. Soon we'll start to program. Okay, I'm going to do one more lecture. I'm going to give you some tools on doing some design and algorithms, that kind of stuff. Then we'll start to program. Okay. So today we're going to talk about arithmetic expressions. And if there's one thing I forget more than people's names, and that's to turn this off. I never have battery. You know? I actually have two for that because I keep forgetting to turn this off. So this is roughly chapter 2.1 through 2.5. Slides are here. We're going to be using GitHub. If you want to go ahead and get those programs going. Here's a useful link. I put it at the beginning, but this has the operators and precedence table. Nice and clean. The outline we're going to do today is first we're going to talk about operators. Then we're going to talk about some different types of operators. Then we're going to talk about converting between types. If we don't finish this part today, we will do that tomorrow in lab. Okay. So by the end of the class, you should know how to use some operators in Java. You should understand precedence. You should be able to read expressions. You should be able to distinguish between binary and unary operators. When I say unary, what do I mean, Ashley?
Unitary operations are basically plus or minus.
Well, think we have one operand. So binary, we think of like 1 plus 1. Unary would be we just have 1 plus. Okay? Java has some of those in its language, and we'll go over those today. You should be able to interpret code that uses this special type of syntax which does an operation and an assignment. You should be able to apply some typecasting and then recognize some issues with doing integer division. So, what are the Java arithmetic operators? There are many others, but we're just going to do math today. Just as you would expect in any programming language, we can do math. All right? We can add, subtract, multiply, and divide, and a few others. We have very well-defined rules. Now, Eric, how did you learn operator precedence, math precedence in grade school? How I learned it was, please my dear Aunt Sally. Parentheses, multiplication, division, addition, subtraction. Eric, where E is exponent, right? Yeah. I'm so old, we didn't even have exponents. We just multiplied a bunch of times. You like that one, Eric? You like that joke? That's not the way it is in Java. Okay? The way Java works is we do precedence by rank, 15, 12, 11, for example, and then associative order, which would be left to right or right to left. So, if you look here, you see multiplication, division, and modulo are the same precedence. So how Java will resolve an equation with these expressions in it is their appearance left to right, not math and division. That's how Java does it. It takes a little bit of getting accustomed to if you're used to the please my dear Aunt Sally for so long. Okay? But precedence, then associative, then order. Of course, and we can control that, obviously, with parentheses. Parentheses have the highest precedence. So we can control however we want it with the parentheses. But you've got to remember left to right. Things on the same rank. Everybody should be able to recognize this stuff. Parentheses is ordering. The asterisk is to multiply, since X is a letter, right? The slash is division. This is the modulo operator. Patrick, what's modulus?
The modulus is it does a division and then it takes the remainder.
Yeah, it's the remainder. Then we have addition and subtraction. Does anybody know any other math that's not included here? No, that's it, right? It just what? Yeah, that'd be the caret. That'd be the caret. But we could also get that by there, right? Okay. No surprises. The only thing to get accustomed to is the left-right order for stuff of similar rank. It's the only difference. So, I'm going to go through these polls. They're broken. This first one's broken. But it's the easiest, so that's okay. So here's the equation. Double D is equal to 3.0 divided by 2.0 plus 1. Right, left to right. There's no confusion on precedence. This resolves first to 1.5, then we add 1. You can see in the earlier section, most everybody got it right. Okay. Now the reason why I didn't reset this poll is because you note the URL. For whatever reason, when I created these, poll everywhere, put everyone on the same URL. So we can't use them. Because if you go to the previous one. So what do we do? For this poll, we want to do a show of hands. So here's the statement. Int I is equal to 3 divided by 2 plus 1. Think about that for a second. Raise your hand if you think it's 0. Nobody? Raise your hand if you think it's 1. Raise your hand if you think it's 2. Most of you. Raise your hand if you think it's 2.5. Some of you. Raise your hand if you think it's 3. Nobody thinks it's 3. Curtis, why do you think it's 2.5? Yeah? Who said it was 2? Nick? Why is it 2? Why do you think it's 2?
Because int only stores the integer, doesn't carry to the decimal place like double would.
Yeah. These are whole numbers. So we don't have half these in there. But now why isn't it 3? Because 1.5 rounded is 3, right? I already asked you, Brian, why isn't it 3?
Because it doesn't round up, it rounds down.
Just because it doesn't round up, it rounds down. Alex, what do you think?
I had fun with this.
Joe?
Okay.
Joe's exactly right. So even if this was 1.999999, Java would still resolve this to 1. Because it doesn't round at all. It doesn't round up or down, it just drops everything after the decimal. And clearly that can cause problems. Let's say we were doing paycheck calculations. How awful would that be if we lost everything after the decimal point? For me, that's most of my check. Think about that for a second. Right? Cats are, oh yeah, I get that. He don't make much money. That's what that means. So, that's what we've got to watch out for with integer math, because we're doing math with integers. And with math with integers, it does not have decimals. Java is brutal. It doesn't try to guess how you want to treat it with rounding. It just says, I'm going to chop it off. Look at this next one. We have a string. String S is equal to string 3 divided by 2 plus string 1. Raise your hand if you think this will get a compiler error. Nobody? Raise your hand if you think this will be 2, the string 2. Raise your hand if you think this will be the string 2.5. John? Raise your hand if you think this will be the string 3 divided by 2 plus 1. Curtis, Alex? What's your name? Where's your card? Hiding behind this one's mix. Raise your hand if you think it would be 3 divided by 2, 1. Yeah, so what's going on here, for those of you that didn't raise your hand, is that it's not going to treat this as math and then try to solve this expression. And it's also, this is not a string. This is a plus operator. So this is one of those conveniences, the syntactic sugars that Java developers do, because we do a lot of string concatenation. So they'll allow us to add strings. So what does adding strings mean? It means plopping them 2 together. So plopping them 2 together would give you this, and not this. So any questions about that? This is, I talked about strings get treated a little differently. This is a case of it. We can add strings. It makes sense to be able to add strings. We use a lot of strings a lot in programming. Let's take a look at this one. string s is equal to the string 1 divided by 2 minus the string 1. Raise your hand if you think this will be a compiler error. About half of you. Raise your hand if you think this will be -1. What about divided by 2? What about 1/2, 1? What about 1/-21? So, now, not everybody raised their hand here, and no one responded to any of these. So there's something going on. So it will be a compiler error. Because it's obvious what adding two strings together means. In this simple case, it might be obvious what you could interpret subtracting strings to mean, meaning strip out the 1. But what if this was 1 divided by 2 plus 1? Which one would we strip? Which one would we remove? The first one or the last one? All of them? Now we start to have some ambiguity, and the language developers say, nah, I'm not going to give you any convenience there because there's too many different ways it could go. String concatenation, however, there's only really one thing that makes sense. So they don't let you subtract strings with this nice little minus operator. They don't let you divide strings or modulo strings or exponent strings or anything else, but they will let you add. Now, what about here? We have string s equal to the string 1 divided by 2 plus 1 plus 2. Who thinks this will become a compiler error? Some of you. Who thinks this will become 3? Ashwin? No, not 3. Who thinks this will be the string 3? What about the string 3.5? What about the string 1 divided by 2, 3? You? Yeah? Cat? No? What about the string 1/2, 1, 2? Some of you? Not much confidence, right? A little unsure. So it won't be a compiler error because you can do addition. And this segues into a later topic that we're going to talk about today or tomorrow in lab. What happens is the runtime of the compiler says, okay, we're dealing with incompatible types, so I'm going to change them. In this case, it will change, since the string is the first thing it encounters, it'll change these to 3. It'll change these to strings 2. It'll give you this. Now, if you want to evaluate this expression here, before the string concatenation, you could put this in parentheses, because that's the highest ranking operator. Then it will resolve this and then promote it to a string and add it to that. Okay? Neat? But in this kind of stuff, yeah, in the back? Oh, was it Yanka? Yuka. Yuka. Okay. I couldn't read it, so I was trying to go from memory. The U looks like an N with my bad eyesight. Okay. I can't see anymore, man. It's like once I hit 40, it's like hair going out of my ears and my eyes go out. You know? It's going to happen to y'all too, so laugh while you can. So IDE 1 is this online Java IDE. And I've put these little code snippets in there for you to review. So this is that one, if I print it out, so you can go see, you can go play with these. This is that other question. Someone in the earlier class had asked what would happen if we moved the plus before the string. And so then we're going left to right. It'll actually do this, resolve this equation, and then promote the strings. So in this case, you'll get 3 plus whatever, as demonstrated down here. Yeah.
So strings will never be transformed into integers, but integers are transformed into strings.
Not automatically. Yes, you're correct. But you can do it. But the programmer has to do it.
Okay. Yeah.
Not the runtime.
Mm-hmm.
Right? This is this thing called automatic type promotion, which is the third section of this lecture. And I want to show it to you a little early. Yeah. The basic gist of it is that you'll have these automatic conversions where the compiler can safely do it, or the runtime can safely do it. Like you can safely go from an int to a string without losing any information. But as soon as you start to lose information, the compiler's not going to do anything for you. Like if you try to go from a, let's say, a double down to a byte. You can lose a lot of information there because you don't just have as much bits to store the number. Okay? But that's the gist of it. If it can safely be done, it'll do it for you automatically. With some, you still might get some side effects. Otherwise, it won't. Okay, so these are all here for you to go look at. Summary, we have math just like we think we should, with a little bit of issues, and that data types do matter, and they gotta, it matters if we're doing integer math, and also it matters if we have incompatible types. So we just have to be aware of that. Now let's look at some other operators. So these is just syntactic sugar. These are just language conveniences that the language developers did to make our lives easier as Java programmers. Okay? And they give us these other operators. We have this unary post operator, post increment, and post decrement. So post means after the variable, you have this operator. And what that'll do, reading right to left, is that it'll use the value first and then increment it. Increment variable. We can put plus plus or minus minus before a variable. And what that'll do, reading right to left, is it'll increment the variable, then use the variable. We have an unary minus. Now this makes sense. This will flip the sign. This is like multiplying by minus 1. And for symmetry, we have the plus, unary plus. We can do an assignment. We've already seen this. And what they've done with the language, because we do this often, do a simple arithmetic and assign it to the variable, they give us these compound operators, where we can say plus equals or minus equals. And what happens here is, let's say that we have int a is equal to 5. Then we can say a plus equals 1, and this will give us a is equal to 6. Okay. We do minus equals, divided by equals, multiply equals. And so basically what it'll do is it'll apply this operator and then assign. Okay, left to right. Apply the operator, then assign. That's not the same as we say a is equal to minus 1. It's not going to subtract it and assign. It's going to be like multiplying by minus 1, flip and assign.
Does the unary minus and plus, does that send it to that sign, or does it just flip the sign?
The unary minus will flip the sign.
And what does the unary plus do?
Yeah, so actually that's in this workshop, and I want you to contemplate and address that in the workshop. Because that's a wonderful question. Wonderful question. What would unary plus do? Raphael, what do you think it would do if you wanted to speculate?
Just nothing. Keep the same sign.
Keep the same sign? Yeah. But think about that.
What would the syntax be for the unary plus or unary minus?
It would be like this. So let's say we want A to equal, let's say we have B equal to 6. We want A to equal to minus B. So let's say that A will be equal to minus 6. Then we could also do A is equal to 1 plus B.
You just say minus a, or minus e for a, minus equals or something.
What do you mean? These two are not the same.
No, I'm saying, is there just a way to just like flip and assign the same operator?
No. Because it was.
You just say a is equal to negative a.
Now you can do it with Boolean. You can flip Boolean by doing the not operator. So you can't say A is not equal to B, you flip the sign. Which will flip the value of Boolean. It's easier to do because it's 0. But not, there's no convenience operator for flipping the sign. So, you should be familiar with how this goes. I want you to work in pairs. One of you drives the IDE, the other one drives the survey. Okay? It's the same model. It's the same model. What do you think it'll do? What does it do? Except for this first step, 1 through 5, all use the same value. So you won't be uncommenting like you did before. And also, when it asks you what do you think I would be, only the last value of I, not any intermediate values. Yeah, get it pairs. Is there should be, looks like perfect amount of people.
He's asking me that even coding.
Just want to do the program this time? Sure.
What's that?
Somewhere in there like the bottom.